to our final speaker. Yagyansh Bagri recently graduated with a thesis on categorizing offensive language in social media using machine learning. Yagyansh, you want to take over now?
I'll take
You ready?
over.
Thank
So
you.
So before I begin the talk, I think it was really interesting to see Sugu and Miss Helen talk about data. And it made me realize about this really beautiful line that I came across. It's like data is not only the new oil, but it's the new soil because of the way it has irrigated itself into every single industry, from maybe healthcare to automobile. And the funny thing about my final year thesis is that I didn't know how to code a single line of Python or machine learning algorithm. And the beautiful thing about machine learning and data is that if you have the willingness and if you're willing to learn and enjoy, and you see, you know what, I deploy this machine learning algorithm and it gives out such an impactful solution. And on that note, I'm going to start my presentation. Give me 1 second. Just to confirm, can everyone see it? Okay, perfect. So my thesis was about identifying and categorizing offensive language in social media. And before we proceed, this is just a parental advisory. There's going to be some extremely explicit amount of content. So if you have kids or if you feel uncomfortable, now's a good time to perhaps maybe just don't leave. Just don't leave. I believe you guys will enjoy it nevertheless. So why have I chosen this topic? Like what's the fundamental reason behind me looking into offensive language? Well, offensive language is particularly defined as any type of offense or the using language in such a manner that could disturb a reasonable person. And today we have so many social media platforms. We have Snapchat, Twitter, Facebook, and people are engrossed in it. The engagement has substantially increased because of the COVID-19 pandemic. And a recent research showcased that 13 people are targeted every single minute. So while social media has provided or been a really safe space or a safe haven, for many people, it has provided a very uncomfortable scenario, a scenario where they feel that, well, this is not the right platform to be in. And a recent example that perhaps disturbed the entire US history was the storming of the Capitol. And on 6th of January 2021, just a second. Yeah. On 6th of January 2021, just the beginning of this year, there was this pathetic incident where so many pro-Trump supporters stormed across the Capitol. There were innocent people who got murdered. Some police officers who got baffled by this. And why did this happen? How did a social media platform like Twitter became housed an inciting platform for so many supporters? And this made a social media platform like Twitter to think about their policies, to think, is our narrative right? And subsequently, they had to suspend. This is the first time that happened. They had to suspend the President of the United States account. Now, what is it that I'm trying to achieve through my thesis or through my machine learning model? First, this is my first goal, that perhaps there could be an automated system that could automatically flag and categorize the types of offensive content. Whilst currently there are moderators who could perhaps physically sit and try to identify, oh, maybe this is offensive, maybe that's not offensive, but it is extremely time consuming. Second, it's very important for us to understand if or not a tweet is offensive from a particular data set. And for this project, I used the OLID 2019 data set. It's from a competition conducted amongst universities. And lastly, build a robust and strong machine and deep learning model to detect the offensive text and perhaps help in reducing the menace caused across social media. Now, I'm going to give a really small description about this OLED 2019 dataset. Firstly, it has 14,100 tweets which have been annotated with three particular labels, and it has three subtasks. The first task is we need to identify if a X tweet or a Y tweet is offensive or not. Second, is that particular tweet, is it targeting a particular group, or is it individually targeted? And then thirdly, what's the priorities of those of the offensive levels? Is it high, is it medium, or is it low? Now, when I was trying to, this is a GIF, you guys might like it. When I was trying to think about this problem, I thought, you know what, maybe I can filter it. Maybe I can have a filtering approach that, okay, these are the cuss words, X, Y, Z, W, A, B. Let's just filter every single tweet by having a filtering list. And when I thought about it, I realized, well, the filtering approach won't capture the context of the word being used in a sentence. So if I say that, you know what, I hate Mexican food, I hate it. Well, that's not the same as saying I hate Mexican people, because it completely divulges the information provided in two particular sentences. And it makes us understand that a filtering approach is not robust. Additionally, sometimes people use different spellings to promote or provoke someone. For example, they could perhaps use these kinds of words to perhaps communicate information in a negative manner. So you can perhaps use shit as shite or SGIT as different words. Secondly, now, when you come to think about it, wait, you have explained about what a filtering approach is, but how will a computer understand? Because all a computer understands is numbers. So you can see the baby's also surprised. How are you going to do it? How are we going to process human languages into a computer? And to be very honest, in the past 5 to 10 years, there have been many machine learning techniques and models deployed. Some of the renowned ones are BERT. This is the state-of-the-art machine learning algorithm by Google. The second is by Dr. Yoon Kim, who provided a convolutional neural network to understand and capture the context of various word vectors. Now, moving on, what would perhaps be the building blocks, or how would I make the baselines for my particular project? So what I did, I used a support vector machine for my baseline technique. And I tried to realize that maybe with certain tweaks, with perhaps additional implementations of CNN or LSTM architectures, I might be able to improve the accuracy of my model. And lastly, I divided the data set into a test and training way, just to always optimize the way I go ahead. Now, how's the architecture of my model, and why am I developing it in this manner? And the fundamental difference between my thesis and the research that has been carried out previously is that I'm trying to unify different parameters in a particular technique. Let's say, for example, if Dr. X implemented a support vector machine and a Dr. Y implemented a CNN, a convolutional neural network, is there a possibility that I could unify these two machine learning techniques and help make my model more accurate and more efficient? And the way I developed this model is that first, there's gathering of the entire data set, cleaning of the data set, pre-processing, and finally, implementing the classification technique that I'll be using. Now, these small blocks, I need to, of course, explain it. What I mean by data gathering is that there's the SEM eval link, a SEM eval competition amongst universities, and they provide the OLIT 2019 dataset. What I mean by data cleaning is that many a times in a data set or many a times in a tweet which is provided on Twitter, there are punctuation marks, there are user mentions, there are certain URLs which perhaps are not necessary for the model to go through. So what we try to do, we try to create an emoji dictionary as well. We try to only emphasize on emojis that promote profanity and try to go away with the ones that do not. And finally, we pre-process the data by using one hot encoders. And in the final step, perhaps I try to unify the different classification techniques available. And okay, you know what? I have my data, I've cleansed it, I've pre-processed it, I have used a classification technique, some ML algorithm, some deep learning algorithm. How is it that I'm going to evaluate my model? How do I know that, okay, this model is good? How do I know that my model is not performing well? So, in order to understand that, there were two key performing metrics. One was the accuracy, and the second is the F1 score. Now, the F1 score is the average of the precision. F1 score is essentially precision for your model. And once I had implemented my classification techniques, these were the results that I obtained on a naive based classifier and a support vector machine. And what I want to you to know is that, sorry, well, this was an interesting project. Of course, this was more of a shot in the dark for someone who has no machine learning experience or algorithm experience. It makes us beg to a very interesting question. It makes us think that whilst machines can do so many things, can help us in such an impactful manner, tomorrow, if I open up my iPhone or if I open up my Android phone and say, hey Siri or hey Alexa, how am I feeling? They will not be able to tell us because they can tell us about the weather, they can tell us about how far is Brighton from Edinburgh, but they can never tell us how we feel. And this is just a stepping stone. This is just a stepping stone for machines to understand. If they can capture the context, maybe 5 or 10 years down the line, you could go to your phone and be like, you never know that Siri could be your therapist or someone who can be there for you when you're feeling alone. And feel free to ask me any questions or contact me for further information in the project.
So, sorry. Thank you very much for that, Yagyansh. Well, I just first want to note what a start of a talk, right? I think that's my favorite start of a talk ever. That it's certainly raised the bar a bit. You know, data is the new soil, and you're talking about your journey here from into well, it's a data science or a classifier classifying project. And I'd be remiss if I didn't point, you know, here I'm going to put a thing in the chat, link to the recording of our previous forum meeting where forum member Chloe Russell Sharp presented her classifier evaluation tool, which naturally comes to mind with your project. But first of all, from the audience, is there any question?
I have one actually. So I did a coursework at uni that was working out whether Wikipedia comments were toxic or racist or threatening and all that stuff. It was good fun. And we used like loads of different models, and we actually found that. I mean, we weren't doing anywhere near as advanced stuff that you mentioned, but we found that the simpler models worked really well. Did you find that that was the case up to a point, or?
I will really agree with you, Ash, that initially I thought if it's a classification thing, I could initially implement logistic regression. So, it could be hate or not hate. But what I realized when you try to feed the model with simpler techniques, the accuracy and the F1 score, it's not high. Right now, it's a small data set. This is my observation. If it's 10,000 tweets, logistic regression could perhaps be at the same level to an advanced technique. But what if it's a million tweets?
Mm.
Then that's when the game changes.
Yeah, absolutely. I think so. That's cool.
Yeah, good point on the solution needing to be scalable. More questions, more comments? We're deep into the natural language processing here now.
I just hope I wasn't rushing. I have a really bad habit of perhaps going too fast sometimes.
Your pace was perfect. Sorry, Subu, you had...
I have a question. How have you coped with the data set availability on platforms like Twitter? Because is it still the case that they only have like the last 90 days worth of tweets or something available for free? And that you have to pay for it masses to get backdated stuff?
So essentially, since it's an open competition, I can always paste in the link over here. It's a CodeLab competition. It happens every year. And I just took it from the 2021 year. And anyone can just go onto the link and download the dataset. It has 14,100 tweets annotated across 3 labels. I'll post in the link for you.
That would be awesome. Thank you. The only reason I ask is I used to be involved in a piece of research that was using sort of social media sentiment to predict like outcomes of NHS regulator reviews and also higher education reviews. And just I remember some of the difficulties with obtaining the data set.
No, I can imagine. I was lucky to have it annotated also because if you have to annotate it and gather it, it can indeed be a very tedious task.